Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is Thermodynamics Class 11 Part 6. In this part, we will study about the work as pressure and volume in terms of reversible process. So let's start. Work as pressure and volume for reversible process. Friends, in the Part 5, we studied that W is equal to minus P external into delta V. Now we studied already, this is called for irreversible process, or we can say one shot process. Okay. Now in this we did the experiment in the last video also, that we have a container in which piston is there and this container is filled with 1 mole of ideal gas. So the volume is V initial and the piston is getting the pressure of P external from outside. What will happen? If we give the external pressure, the piston will move inward like this and volume will decrease and the final volume is Vf. Okay. Now we can see the piston traveled the distance L. Clear? In the last for irreversible process also we did the same process. Here just a reminder. So what is happening here? As the piston moves, the work is done and we get the work is equal to minus P Ex into delta V. Now this was the one shot process. See, suddenly we give the external pressure and the volume will change. But in place of this, what if we are giving small pressure? First we give some pressure, some small work is done, then again we did small pressure, small work done, again we will give small pressure and small work is done. So when the work is done in small steps, small discrete steps, then the total work is done on the system is the addition of all the small work done. So how could we write it here? It should be W is equal to integration of all the work, that is summation. So minus will be there outside, summation P external into delta V. We can write like this. Yes. And now the next level is, suppose it is not in discrete step, it is very slowly. We can't even count the steps. This much small change is happening. We are giving the pressure, but we can't even measure on the single step. It means very slow change is there. And that in that case we will say this is a reversible process, because we are already studied that the very slow process is called reversible process. So now we are reaching towards the reversible process. So what will happen when it is a very slow process? So the summation will be changed with the summation is changed to the integration. So we can write minus integration from where? V initial to V final, P external into delta V. We can write like that. So for reversible process, summation will be used. Now in this step, if we want to see what is the relation between work and the internal pressure. Just now we are relating the work with the external pressure. So what about the internal pressure? So we can write this equation in terms of internal pressure. So P external, it should be P internal plus minus delta P. Now delta P is the difference between the external and the internal pressure. That only is the main reason. If the pressure difference is there, then only piston will move. If inside pressure is more, then piston is moving outward, expansion will be there. If external pressure is more, then piston move inward and compression will be there. So the difference plus the internal pressure is equal to the external pressure. So it will be plus in case of expansion, it will be minus in case of compression. So we will take plus minus both. So now let's write W is equal to minus integration V final, V initial, from V initial to V final, and in place of Px we will write P plus minus dP into delta V. Now if we expand this, what will happen? V initial to V final, every time we will write this, it will be P delta V and plus minus dP into delta V. This will happen. Now in that step, we knew that dP into dV is very small value. So it is negligible. So we will leave this value and we will come up with W is equal to minus integration from V initial to V final P delta V. We reach to this expression. Now for ideal gas, we have expression PV is equal to nRT, where P is a volume, V is a volume, N is the number of mole of gas, R is the gas constant, universal gas constant, T is the temperature. Now from this equation we can write P is equal to nRT upon V. Yes, we can write. Now replace our equation, not replace the pressure in our equation with this. So we can write here W is equal to minus integration from V1 to V2. What is V1, V2? V1 is equal to V initial and V2 is equal to V final. Because in the numericals or in the equations in the books, it is not V initial final, V1, V2. So now we are going to write V1, V2. So it is clear. Now in place of P, we will write nRT upon V into delta V. And one more change we are going to do, that delta V we will change with dV, because in the books, as I told earlier, it is mentioned delta V, both are same thing. So this is the equation now. Now take all the constant outside the integration. W is equal to minus nRT integration V1 V2 1 upon V and dV will be there left over. Now for when we remove the integration, what will happen? Log will appear and RT is there. Now we can write natural log V from V1 to V2. We can write like that if we are going to remove the integration sign. So minus nRT log natural log V from V1 to V2, we can write natural log V2 minus natural log V1. Yes, we can write like this. This you will study in physics in class 11. Okay, so don't get confused. We are using this thing here. Now what will happen next? Natural log V2 minus natural log Vn. We will write it in the next step, minus nRT natural log V2 upon V1. And when we are going to change the natural log to the log base E, what will happen? We have to multiply with 2.303. So if we multiply the equation with this, we can be able to change the natural log to log E. So minus 2.303 nRT. Now, what we can write? Log base E V2 upon V1. Fine. So, now we come up to the end of this whole scene and we will get the equation. Work is equal to minus 2.303 nRT log V2 upon V1, and we got our final equation. This equation of work is for reversible process, or we can say very small process. Sorry, not small, very slow process. So then W is equal to minus 2.303 nRT log V2 upon V1. So friends, with this equation, I am going to stop my video here. Don't forget to like, share and subscribe the channel, and don't forget to press the bell icon. Till then, thank you.